Hey everyone, this is James here from the Dev Genie Academy, and in this week's episode we're going to be looking at a camera movement which allows us to move around the scene and interrogate objects that are around us. So without further ado, let's begin. So let's start by creating a new class called camera. This needs to be created in our core package. There we go. And it's very similar to the entities class, but it will be changed later on. So we need a private vector 3f of position and rotation. Let's just import that vector 3f, there we go. And we also need a empty constructor for this camera first. So that's going to make position equals a new vector 3f of 0, 0, 0. And we can do the same for the rotation as well. Obviously we want a constructor for when we're given parameters, so we can have a vector 3f of position and a vector 3f of rotation. And it's just a straightforward constructor at this point. Position equals position and rotation equals rotation. So on to making moves. So public void move position. We need a float x, float y and float z. So again, very similar to our entity package, but first we need to make sure that the z component doesn't equal 0. If that's the case, then position.x plus equals, again we need to cast this to a float, it's math.sine, math.to_radians of rotation.y. This now needs to be multiplied by negative 1.0f and then multiplied by z. We can do a similar thing for the position.z. Again we need to cast it to a float, but this time it's math.cosine, math.to_radians of rotation.y, and we just multiply by z. Copy this entire if branch and change the z component to x. So if x doesn't equal 0, we then do rotation.y negative 90 and change the multiplied by z at the end to multiplied by x. Make sure you do rotation.y negative 90 for both lines. And after this we can then do position.y plus equals y. So that's our move function for the camera. We can then do a public void set position, which is just a float x, y and z. And we do this.position.x equals x, and we can do that for x, y and z. So this.position.y, this.position.z. Okay, so now on to the rotation. So public void set rotation of float x, float y and float z. And we just do this.rotation.x equals x and y equals y, z equals z. Very similar to the set position that we've just done above. And if we copy that function, we can then do a move rotation. So we do public void move rotation, and then we just do plus equals on each line. So this dot rotation dot x plus equals x, same for the y and the z. And then finally we just do two getters for the position and the rotation. Moving on to the transformation class, let's create a new function, public static matrix for f, get view matrix, and we pass in the camera as a parameter. We then need to do two vector 3f's, one for the position and one for the rotation. So that's vector 3f pos equals camera.getPosition and vector 3f rotation equals camera.getRotation. We can then create that empty matrix for f as before. We then do matrix.identity and then matrix.rotate. This time we need to do as rotate, not rotate x. So we do that value as a float still, math.to_radians of rot.x, and pass in a new vector 3f of 1, 0, 0, and we need to duplicate that function 2 more times for the y parameter and the z parameter. The only change we need to make is obviously the rot.y, but we need to do a new vector 3f of 0, 1, 0 for the y, and in rotation for the z. Again, cast that to a float, math.to_radians of rot.z, and a new vector 3f of 0, 0, 1. We can then move on to doing the matrix for the position. So we do matrix.translate, but we need to do negative position.x, negative position.y, and negative position.z. This is because we're moving all the world objects in the opposite direction of where we want to go. So in the render manager, let's create those uniforms. We need to create a uniform for the projection matrix and also a uniform for the view matrix. So don't forget, but in the render method we need to set those uniforms. So we need to do shader.setUniform of projection matrix, and if you remember right back to the very first episodes where we created the window class, we've already got that function lined up. That's window.update projection matrix. And then finally we can then do the view matrix, and we do that as transformation.getViewMatrix and pass in a camera. At the moment we don't have one, but we can set that in the render method. So entity and camera is required now. So in the cleanup method we need to make sure we do shader.cleanup, because that's a function that I missed from a few episodes ago. So if you haven't already got that in, make sure it's there. And in the vertex fragment shader we need to add those matrix 4Fs. So that's the projection matrix and the view matrix. And again, this needs to be in a very particular order. So the projection matrix needs to be first. So that's projection matrix multiplied by the view matrix multiplied by the transformation matrix. So back in our test game, we have got the error in the render, but we'll get to that in a moment. We can get rid of all three of these, and I'm going to have a new list of values here. It's extremely long, so I will add that into the description down below. If you just copy that in and paste it in here, that will give you a rendered of a cube, and you can see how long that information is. So let's create a private camera, and in our constructor, let's make camera a new camera. We also need to have a vector3f of camera inc, and we can set camera inc to a new vector3f, just empty for now. Actually, let's just do 0, 0, 0. Okay, in our input we can get rid of all of this. We don't want to make that background change color anymore. We need to do camera inc.set 0, 0, 0, and if window.isKeyPressed, and we'll look for the GLFW key W, there we go. If that key is pressed, then we can do camera inc.z equals -1. And if we copy that if statement and change the W key to S, we then make camera inc.z equals 1, and then we can copy both of those and change the W component for A and the S component for D, and change camera inc.z to X, and that should do the left and right. So next up we can also do up and down, so Z and X for this one, and that camera inc needs to change to Y. So that's some basic camera movement set up. So in our update method we can get rid of all that colour stuff. In fact, let's just get rid of all of it. Let's do camera.movePosition of camera inc.x, camera inc.y, and camera inc.z. So that will move our camera in the position that we've set. We also need to do a private static final float of camera move speed, and I'm going to set mine to 0.05f, but you can set yours to whatever you'd like. And back in the update method we can then do camera inc.x multiplied by the camera move speed, and we can do that for all three parameters. So multiply them all by that camera move speed, and after this then we can then do entity.increment rotation, and that's going to be by 0.0 for the x, 0.5 for the y, and 0.0 for the z. So that should be the update method done. So in the render, all we need to do now is just add that camera to the render method, and set clear color needs to take all that color out, and just do 0.0f for the three color components. And now there should be, there we go, there they are. Get rid of direction and color because we don't need those anymore. We also need to change the entity's position, so instead of it being 1, 0, 0, change it to 0, 0, 5. And when we run that now, we can see the cube is rendered, but there's parts of it missing. So if you go into our window manager class, make sure you comment out GL enable cull face and GL cull back. So when we re-render that now, we can see that all faces of the cube are rendered correctly. So that's it for this week's episode. Thanks very much for watching. If you do have any questions, please leave them down in the comments below, and I'll see you next week. Thank you.